Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ghazali. Today, my team and I are going to present our assignment project. This is our group members. I'm going to present the oscillator 1, which is the type of bloom rate oscillator. So for this oscillator 1, to construct the circuit, I must do the calculation first. First thing first, I must assume the C1 equals C2 is 1 nanofarad. So I do this calculation. Then I get the value which is 159.15 kilo ohm, or in range of 150 kilo ohm to put the resistor value. So to get the value R2, I must assume first the R1 value is 10K. Then I do this calculation, then I get this R2 value, which is 20 kilo ohm to 22 kilo ohm. So then I construct the circuit. And this is the circuit. This is the value for 10K. As you can see, there is the value for 1 nanofarad and 58 kilo ohm, where I did the calculation earlier. This is the 22 kilo ohm that I do the second calculation. So let me run the simulation. As you can see, I get the sun wave output of waveform. And the frequency I got 984 Hz, which is nearly to 1 kilo ohm, where the question in the assignment wanted. Okay, that's all for me. Thank you.
Hi and Assalamualaikum. My name is FARHAH BINTI JAAFAR. So I will present about oscillator 2. So in oscillator 2, it's using type of Wien bridge oscillator. So in the lab sheet, it was given 20 kHz for resonant frequency and 15 volt for DC supply. So for the calculation, is find the value of component, which is resistor, capacitor, and ratio of waveform. So to find the resistor, I'm using a formula of frequency resonance, which is FR equal to 1 over 2 pi RC, and I assume capacitor is 200 nano. So I got the value of resistor is 40 ohm, but I'm using 32 ohm for resistor in the multi-sim software to get the output value that what had given below. Then to find the ratio of amplifier resistor, I'm using the formula of gain, which is R1 divided by R2 equal to 2. For oscillation to commons, the value of R1 over R2 should be made slightly greater than 2. So I put the formula of gain is equal to 2. Same goes in lab 4 before. So I assume R2 is equal to 20 kilo. Then I got the ratio value is 40. So this is circuit of oscillator 2. So I will run it. So as you can see, the frequency is 19.7 kilohertz. So it matched with the value that you want, which is 20 kilohertz. And the maximum value is 2 volts. So to get the smoother output waveform, use 40 ohm. So you can see that in 40%, it will be the smoother output waveform, and it's accurate with the calculation before. Okay, thank you.
Assalamualaikum warahmatullahi. My name is AISHA JIBRIL. For this assignment, my part is the active low pass filter, and I was given the cutoff frequency, which is 8 kilohertz. So here is the calculation. For the calculation, we have the cutoff frequency equals to 8 kilohertz, and the formula is for the cutoff frequency is 1 over 2 pi RC. So I assumed R1 equals to R2, which is 1 kilo ohm, and for C1 equals to C2, which I assume equals to 19 nanofarad. So for the cutoff frequency, 8 kilohertz is equal to 1 over 2 pi r times 19 nanofarad. R equals to 1 over 2 pi times 8, 8 kilohertz times 19 nanofarad, which is equals to 1.047 kilo ohm. So for the second order butter response, which I assume R1 equals to 1, which I assume is equals to R1 over R2 is equals to 0.586 and R2 equals to 1 kilohertz. So for R1 is equals to 0.586 times R2, which is equals to 0.586 times 1 kilohertz, which is equal to 582, which is equals to 582 ohm. And here is the for my circuit that I did. For the simulation, this is the package that I already constructed. So for the output, what I got was for the work folder, our output, this is my output, and it's supposed to be 8.6. This is exactly what it is, and this is 0.5 kilohertz for the output, because we have to be in this little area before we can get our accurate accurate result. So I think this is all from me. Thank you so much.
My name is Muhammad ZULHUSNI bin Ahmad Jais. My metric number is B0820103333. And today I will be presenting about rectifier. In a nutshell, a rectifier is an electrical device which converts an alternating current into a direct one only, and into a direct one by allowing a current to flow through it one direction only. In other means, it converts negative phase of the AC into positive phase, and it will produce a constant positive output to supply the load. Okay, over here, this is my calculation of the rectifier that I will show in a minute. Okay, this is my circuit design. This circuit consists of 2 volt of VPK 30 Hz, one full bridge rectifier, one UF capacitor, and 100,000 kilo ohm of resistor. And I will using two type of oscilloscope, which is provided by the multisim and the Tektronix. Now I will like to show some demonstration about the output. Alright, if you can see here, the red lines represent the output from the rectifier. You can see it's ripple all the way in a positive phase only, while the blue ones is the output from the capacitor, which is an LPF circuit, which is low pass filter. We can see the ripple voltage is 262 millivolt, which is quite the same as we calculate. Let's calculate over here. The ripple voltage is 200 millivolts. So in theory, the ripple voltage is around 200, but in the simulation that we got, we have here is 262 millivolts. Okay. And for the tectonics, we can see the output here over here is quite same. Okay. Alright. That's all for me. Thank you and Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Nabilah binti Muhammad RODZI, and my matric number is B08201019. I would like to present my pair, which is voltage regulator and load. Voltage regulator is the component of power supply that ensure a steady, constant voltage supply through all the operation condition, and the output voltage remain the same even if the input DC voltage varies or the output load connected to the DC voltage changes. For this project, we are requested to construct voltage regulator type of OM shunt regulator circuit with the given specification is 5 volt as the output voltage. Before we construct the circuit, we must find all the parameters by doing calculation. Okay, firstly, we find the value of resistor using the formula of power P equal to V squared divided by R. Then we substitute the value of P is 1 watt and V is 5 watt. And we get the answer is 25 as a resistor load. Second, we calculate the current using the power formula P equal to current times volt, and we substitute all the value, and the final answer is 0.2 ampere. Lastly, we calculate the value for Vz. Vz equal to R3 divided by R2 plus R3 and time V naught. We assume the R2 is 40 ohm and R3 is 100. And V naught are given 5 volt, and the answer for value of Vz is 3.571 volt. After we get all the parameter, we construct the circuit. So this is my circuit for voltage regulator. We put the multimeter at load because we want to measure the V naught, and we try to run it. So for voltage output, we get 5.061, which is nearly to 5 volt. And voltage across the Zener diode is 3266 volt for the simulation. So OM as the comparator in this circuit, when the output increase the sampling, circuit will send feedback to the signal to the comparator. Then the control signal will decrease the shunt current and it will be less load current. And lastly, it will keep the regulated voltage from rising. Okay, next part is load. For the load, we using the same circuit, voltage regulator. We use the wattmeter to measure the watt and put at the load. Then for value of watt, we get 1.025 watt, which is similar to the given specification, power equal to 1 watt. Thank you.